All right, more on the graph of a function, section 3.2. The last example, we looked at a graph and found some information. Now we're going to look at the function itself and find information that way. So the first question is the point 1 1/2 on the graph of f? Well, what would have to be true if it is? We'd have to plug in 1 for x and get 1/2 as a result. So let's plug in 1 for x and see if we get 1/2. We do, so the answer is yes. That point would be on the graph of that function. And we don't even have the graph, we just have the function itself. For x equals 2, what is f of x? Okay, so in other words, plug in 2 and find out what that is. So it's 2/3. And so what is the coordinate we just found? We found x is 2, y is 2/3. If y is 2, f of x is 2, what is x? Okay, so we go back to our function, and in the place of f of x, let's put a 2. Right? We know what f of x is. They told us it's 2. Now we're supposed to solve for x. So what would you do first? Yes, multiply both sides by x plus 1. It'll cancel on this side, leaving x. Okay, subtract x from both sides, subtract 2 from both sides. So we get what? X equals -2. Subtract x, that leaves 1x here and 0 there. Then subtract 2, that leaves -2. So we found x is -2. What's the coordinate? -2, 2. We were given the y, we found the x. What is the domain? Okay, we can't look at a graph now. Remember our steps. Start with all real numbers. If there's a variable in the denominator, there is. Exclude from the domain all values of the variable that make the denominator 0. So let's find out what makes x plus 1 0 by setting it equal to 0. Of course, that's -1. The third question is about radicals of even index. We don't have that. So the domain is everything except -1. So we can say you can go from -infinity to -1, don't include it, and then union that with 1 to infinity. That's how we make a hole in the number line. Or it doesn't say what format to put it in, but we could also use set builder notation and say all x such that x is not -1. What are the x-intercepts of the graph, if there are any? Okay, how do you find the x-intercepts? We let y, which is the same thing as f of x, equals 0, right? That's how you find the x-intercepts. So 0 equals x over x plus 1. Multiply both sides by x plus 1, and we get 0. So what did we find? What are the points on the graph? X is 0, y is 0, right? The origin. And finally, list the y-intercept if there is one. Well, that's kind of a trick question. Well, I'll go ahead and work it, but guess what? We already know what it is because this is the intercept they share. But let's prove it. To do that, we let x equals 0, so we find f of 0. We get 0 over 1, which is 0, and indeed, we did get what we suspected we would get. But if it hadn't been the origin, then this is what you would do to find whatever it was.